Okay, because to find the standard matrix, so how we do it, we look at the image of TE1, TE2, TE3, right? So I'm going to find, and these are just going to be like the column of the matrix. So I'm going to start with E1, and we know that E1 is 1, 0, 0 in R3. And first we're going to dilate by factor of 5, so that means we're going to multiply this by 5, 5, 0, 0. That's the first one. And then we're going to reflect about YZ plane. When you reflected about YZ plane, so Y and Z are going to stay the same. You're going to change the sign of X, which is negative 5, 0, 0. And then you're going to rotate counterclockwise about the x-axis by angle of 60 degrees. So first of all, let me tell you the rotation matrix. So the rotation matrix in YZ plane is just this rotation matrix. So let me should I call this? Maybe it's a rotation about the y, right? So this is going to be, is it counterclockwise? Yeah, counterclockwise rotation about the y-axis, and then that will be this. So let me write it on this corner. So that's cosine theta, 0 sine theta, 0, 1, 0, negative sine theta, 0 cosine theta. That's our rotation. Theta here is 60 degrees, so this will turn into this. Cosine of 60 is a half, 0, square root of 3 over 2, and this is 0, 1, 0, negative square root of 3 over 2, 0, and 1 half, right? This guy right here is 1 half. That's the rotation matrix about the y-axis. Okay, so then this will turn into, under this mapping, right? Under this rotation, this will turn into negative 5 over 2, and then the other one will be 0, and then this will be positive 5 square root of 3 over 2. So E1 is mapped to this, so this is going to be the first column. And then you do same thing with the E2. So E2 is 0, 1, 0, so you dilate it by factor of 5, that's 0, 5, 0, and then you reflect it about the YZ plane. That means keep the y and z the same, change the sign of x, which is still 0. So this is still going to be the same thing. And then over here, now we're going to multiply this vector by this matrix, right? So so basically that's going to be 0 right here, and then 5 right here, and then this one is 0. So this will be that. And then do same thing with the E3. So E3 is 0, 0, 1. This will turn into, after dilation, it will be 0, 0, 5. And then after reflection in YZ plane, again, you'll keep the Y and Z the same. That will still be the same. And then you'll rotate it now by 60 degree, which is going to be 5 times square root of 3 over 2. And then 0 here, and then 5 over 2 here. So now the matrix, let's call that standard matrix. So matrix TA is the standard matrix. The first column is going to be this guy, negative 5 over 2, 0, 5 root 3 over 2. This is the second column, 0, 5, this is 5, 0. And this one is the third one. So 5 square root of 2 divided by 2, 0. So this will be the standard matrix of this transformation that applies to those transformation rules.